Hey everyone, and welcome. So today, we're going to pull back the curtain on something we do a dozen times a day, searching. We're going to follow one single question, a query, on its absolutely wild, high-speed journey inside a database. We'll see exactly how a simple ask turns into a super complex but lightning-fast answer. All right, let's jump in.
I mean, think about it. You type something in, hit enter, and boom, the answer is just there. It feels like magic, right? But what is actually happening in that split second? Well, it's not magic, but it is this incredibly cool, super complex dance of pure logic and engineering. And this right here is the language of that dance. It might look a little intimidating, but this is an SQL query. SQL stands for Structured Query Language, and it's basically the formal way we ask a database a question. For our story, we're asking something pretty specific. Hey, can you give me the names of all the sailors who have reserved a red boat? So yeah, this little line of code, that's going to be the hero of our journey today. Okay, so we've asked our simple question. That one little line of code kicks off this whole incredible journey. See, the database can't just, look for the answer. No, it has to follow a very precise set of steps to find all the right pieces, put them together, and then hand that answer back to you. And right away, we hit our first major challenge, and it is a big one. A database can have millions, even billions of records. So how on earth does it find the handful of things you asked for without getting totally lost in all that data? One thing's for sure, it's not going to read every single entry one by one. I mean, can you imagine? That would take forever. So it has to be smarter about it. So the query's very first stop is this brilliant little piece of software called the Query Optimizer. Now, the best way to think about this is like a master strategist or maybe a master librarian. When you ask that librarian for a specific book, they don't just start wandering aimlessly down the aisles, right? Of course not. They know the exact shelf, the exact spot to go to find it. The Query Optimizer does the same thing for your data, and it saves a ridiculous amount of time. And this really shows you the two completely different ways a database could approach this. On one hand, you've got the brute force method, a full scan. That's like deciding to find one sentence in a library by reading every single book. It's not smart. Then you've got the smart search, the index seek. This is like using the library's catalog to jump directly to the right book and page. The difference in efficiency isn't just big, it's absolutely astronomical. So how does that smart search actually work? Well, a super common way is with something called a B+ tree index. The reason these are everywhere is because they are just so darn efficient. It works like a super organized decision tree. The database starts at the very top, at the root, and at each level it makes a decision that narrows down the search, and then narrows it again, until bam, it lands on the exact little chunk of data it was looking for. You can really think of it as a GPS for your data. Okay, so we've got a smart path. The optimizer figured out the quickest way to find the data, but there's another problem. Remember our original question? We need info about sailors and boats and the reservations that connect them. That data is almost never stored all in one giant file. It's split up. So how do we solve that? The solution is a really powerful operation called a join. And honestly, it's exactly what it sounds like. You can think of it as the database solving a jigsaw puzzle. It takes these different pieces of information from separate tables and joins them together using a common piece of data, like, say, an ID number. All right, let's see this in action. Here's our first puzzle piece, the sailors table. Super simple. It's got the sailor's name and their unique ID, which we're calling SID. But look closely. There's nothing in here about what boats they've reserved, right? And here's piece number 2. This is the reserves table. This one connects a sailor ID to a boat ID. This is the crucial link, the glue that holds it together. But again, notice what's missing. No sailor names and no boat colors. It's literally just the connection. But when the database performs a join using that common sailor ID, voila, it creates this temporary combined table. And now, all of a sudden, it can see exactly which sailor's name goes with which boat reservation. It's put the pieces together. Now for our full question, it would do this one more time to bring in the boat's color from a boats table. Pretty neat, huh? So, just to recap, we found the data, we assembled it, we should be done, right? Well, not quite. Our query isn't happening in a vacuum. On any popular website or app, there are thousands, maybe millions, of other things happening at the exact same time. So how does the database stop it all from becoming total chaos? Just think about this for a second. What if two people tried to update the same bank account at the exact same time? It would be a disaster. Without any rules in place, one of those updates could just get overwritten and disappear. The final balance would be totally wrong. This is a classic problem called a concurrency problem, and it's something databases have to deal with constantly. The system that prevents all this potential chaos is called concurrency control. And really, it acts like the ultimate traffic cop for data. It's standing in the middle of a massive intersection, directing thousands of requests, making sure nobody crashes into each other and corrupts all the precious data. And one of its most important tools is the idea of locking. Let's break this down. A shared lock is kind of like a library book that has to stay in the reading room. Lots of people can come and read it at the same time, no problem. But an exclusive lock, well, that's like checking the book out and taking it home. While you have it, nobody else can read it or write in it. This simple system is absolutely crucial for keeping data correct, especially when things get really busy.
So our little query has been on quite the adventure. It got optimized, its data got pieced together, and it safely navigated all the traffic from other operations. Its long journey is finally coming to an end.
And how long did all that take? Well, this is the mind-blowing part. All of that complexity, the clever pathfinding, the jigsaw puzzle solving, the intense traffic control, all of it happens in just a tiny, tiny fraction of a second. This is the incredible speed of modern information. So why does any of this invisible work matter to you and me? Well, it means that every app, every website we rely on every single day is built on this amazing foundation. It's all about speed, finding that needle in a digital haystack instantly. It's about integrity, making sure your data, like your bank balance, is always correct. And it's about concurrency, letting thousands of us book flights or buy products at the exact same time without the whole system just breaking a sweat. You know, our world runs on data, and it is only getting bigger and faster. Think about web-scale apps or the constant flood of data from all our smart devices. The journey of a single query is only going to get even more complex. So the real question is, how are we going to keep making it all feel like magic? Thanks so much for joining me on this one.